In this video, we will be continuing our discussion on the algebraic identities from the chapter of polynomials. In the previous video, we have seen 4 identities, and in today's video, we are going to see the next 4 identities, which involves not just polynomial or expression with degree 2, but also expressions whose degrees are 3. The highest power here is 3, right? So previously we had only binomials. Okay, we had only 2 variables involved, and now and the highest degree was also 2. Okay, there are only 2 variables, x and y, and the degree is the highest degree is 2, so it's x squared, y squared, and so on. So the highest degree is 2. So the fifth identity is of degree 2, but it involves 3 variables, so it's trinomial. Okay, so far we have seen only binomials, so now it's a trinomial whose power is 2, and then we will also see some binomials whose power is 3, and we have 3 different identities with degree 3 or with power 3. So we will use these identities again for the same purposes as we talked about in the last class, which is to factorize some algebraic expressions or to make some computations. Okay, basically the identities are equations which satisfy to be true for any value of the variables which are present in those identities, and we will use them to either factorize an algebraic expression or to compute some value using these identities. Okay, so the first one is x plus y plus z the whole square, which is x squared plus y squared plus z squared plus 2xy plus 2yz plus 2xz. So it's a pair. Each of these variables appear in pairs here: x and y and z, and x and z. Okay, then we have x plus y the whole cube, which is given by this expression. Then we have x minus y the whole cube, so instead of plus y, it is now minus y the whole cube, and we get this particular expression. So it's for x plus y the whole cube, it's x cubed plus y cubed plus 3xy into x plus y. We can expand this particular term here, and we can write this as x cubed plus y cubed plus 3x squared y. So basically we are multiplying the 3xy with this x, so 3x into x is 3x squared, and then we have the y, so it's 3x squared y. I'm just opening up this bracket here, so it's 3x squared y plus 3x y squared. Okay, so we can write it either in this form or in this form, and we will see expressions appearing in both these forms, so we have to identify which form it is in and then use the appropriate identity to either factorize or to perform the computation. Okay, similarly for the next one, we can open up this bracket, and we will have it as x cubed minus y cubed minus 3x squared y, and minus into minus will be plus 3x y squared. Okay, so I have just opened up these brackets, so the general form of the identity is here, and if we open up this bracket by multiplying these terms, we get this second form. So both of them are equal. Okay, so they represent the same thing, we've just represented them in different ways. Okay, and then the final identity is having this form, which is x cubed plus y cubed plus z cubed minus 3 times xyz, and that can be written as x plus y plus z multiplied with x squared plus y squared plus z squared minus pairs of those variables, minus xy minus yz minus xz. So each of these variables are appearing in pairs: x and y together, y and z together, and x and z together. Okay, so we have these identities now, and in this video we will solve some problems related to these identities, and we will do more and more examples. So I will split the classes into multiple sessions so that we can concentrate on each types of identities separately, and we are able to solve various problems using these identities and things will become clear for us. Okay, so let's do an example first of all. So we have here an example of 4a minus 2b minus 3c the whole square. So obviously this takes the form of x plus y plus z the whole square. So clearly this is of the form x plus y plus z the whole square, which is our identity. So in place of x we have 4a, in place of y we have minus 2b, and in place of z we have minus 3c. So we just need to substitute these in the right hand side of the expression to evaluate this expression or evaluate this polynomial, okay, or the algebraic expression. So we see that x equals 4a, y equals minus 2b, and z equals minus 3c. So we just have to substitute in the right hand side of the expression. Wherever we have x we'll put 4a, and wherever there is y we will put minus 2b, and wherever there is z we will put minus 3c, and simplify the expression. So we can write our 4a minus 2b minus 3c the whole square. We can write it as I'm just going to use this expression here, so x square. So in place of x we have 4a, so it's 4a square. Okay, and we should remember to put the bracket. Okay, it's 4a the whole square. Okay, if you just write 4a square, then you will forget to square the 4, and you will go wrong with your calculation. So it's 4a, so x is 4a, so it's 4a the whole square, plus y is minus 2b, so it's minus 2b the whole square, plus z square, so z is minus 3c, so and z square is minus 3c the whole square. And then we have plus 2 into x into y, so plus 2, x is 4a and y is minus 2b, plus 2 into y into z, so 2 into y is minus 2b, and z is minus 3c. And then we have the last term, plus 2 into x into z. X is 4a and z is minus 3c. So now we just have to simplify this. So we get 4a the whole square will be 16a square, minus 2b the whole square is plus 4b square. So when you square a negative we get positive, so it's plus minus 2b the whole square is 4b square, and similarly minus 3c the whole square is plus 9c square. So minus 3 square is plus 9c square. And then we have 2 into 4a into minus 2b, so 2 into 4, 8, 8 into minus 2 is minus 16, so it's minus 16ab, so the plus into minus will become minus, so we'll have it as minus 16a times b. Then we have the next term, 2 into minus 2 is minus 4, minus 4 into minus 3 is plus 12, so plus 12b into c, so plus 12bc, so plus 12bc. And then the last term we have 2 into 4, 8 into minus 3 is minus 24, a into c, so it's minus 24 ac. Okay, so this expression evaluates to 16a square plus 4b square plus 9c square minus 16ab plus 12bc minus 24ac. So we have seen how we can use the identity to expand the given expression, which is 4a minus 2b minus 3 the whole square. So we just used the x plus y plus z the whole square identity and expanded this term. So we just had to figure out what is in place of x and what is in place of y and what is in place of z, and just substitute them in the correct positions and evaluate the expression. So we get the resulting expression, which is our final answer. Okay, the next example that we're going to see is given an expression, we will see how to use it for factorizing and finding the factors of the expression. Okay, so we have to factorize this expression 4x squared plus y squared plus z squared minus 4xy minus 2yz plus 4xz. So we are when we look at this expression, it is having the form of x squared plus y squared plus z squared plus 2xy plus 2yz plus 2xz, which is basically x plus y plus z the whole square. Okay, so we need to figure out now what is x, what is y, what is z, and then we will be able to factorize this. So we want it in the form of x square. So we have 4x squared, so we can write the 4x squared as let me write the question all over again. So we have 4x squared plus y squared plus z squared minus 4xy minus 2yz plus 4xz. Okay, so the 4x squared can be written as 2x the whole square. The y square can be kept as it is, plus y square. But when we look at these combinations here, when we have x and y product, there is a negative sign here. Similarly, for y and z, there is a negative sign here. So that means either x is negative or y is negative. In this case, because there is a negative sign in front of the yz combination, either y is negative or z is negative. Or and since this is positive here, for x and z combination, x and z must both have the same sign. That means they should either both be positive or both be negative. So the best way is to have the y as a negative form. So that will be plus, we'll have it as minus y the whole square. Okay, so minus y the whole square will become plus y squared, which is this, and the z square will remain as z square as it is. And then we have so we have in terms of x squared plus y squared plus z squared, the first three terms. Then we have 2 into x into y, so plus 2. In place of x we have 2x, so that's 2x. So in place of x square we have 2x the whole square, so 2 into x, which is 2x in this case. So 2 into 2x, and y is, in place of y we have minus y. So now when we multiply this, we get 2 into 2x is 4x, 4x into minus y is minus 4xy, we get this term. And then the next term is 2yz. So after 2xy we have 2yz in the identity, so it will be plus 2 times y. In place of y we have minus y, and in place of z we have z itself, so it's minus 2yz. And then the final term is 2xz, so that will be plus 2 times our x is, in place of x we have 2x, and in place of z we have z as it is. Okay, so now if we compare this with our identity, in place of x, now we have it in our form as we need it. So it's x squared plus y squared plus z squared plus 2xy plus 2yz plus 2xz. So in place of x we have 2x, in place of y we have minus y, and in place of z we have z. So we just have to substitute them accordingly. So it will be, that will be equal to, so that is going to be equal to 2x minus y plus z the whole square. So it is x plus y plus z the whole square. So we have written it in a form which matches our identity, and then we see which variable maps to which other variables. So in place of x, so the term x in the identity maps to 2x in the given expression. The term y in the identity maps to minus y in the given expression, and in the term z maps to z in the given expression. So using this, we have x plus y plus z the whole square. So in place of x we have 2x, so it's 2x. In place of y we have minus y, so 2x minus y plus z the whole square, and whole square means it is something multiplied with itself, so we can write that as 2x minus y plus z multiplied with itself. So that's 2x minus y plus z. So we have done the factorization of the given algebraic expression using the identity of x plus y plus z the whole square. So the important thing here is that when you're given an expression, of course you are supposed to remember the identities and identify with which identity the particular given expression resembles or matches, and then you have to represent that in a form that relates with the identity and then put the terms in the correct positions, and you'll be able to solve the problem. Okay, now let us do one problem from the exercise set. So from exercise 2.4 we have question number 4, which is using the identity to expand a given expression of power 2. Okay, so I'm doing only one such example. There are many sums in this particular section, so I'm doing one of them. So clearly when we look at this expression, it is of the form x plus y plus z the whole square. So in place of x we have 1 by 4 into a, that is a divided by 4. In place of y we have minus b by 2, and in place of z we have plus 1. Okay, so we just have to use this identity x plus y plus z the whole square and use the identity for it and substitute the corresponding values, and we'll get the answer. So basically what we have here is, in place of x we have a upon 4, 1 by 4, a is a by 4. In place of y we have minus b by 2, and in place of z we have 1. Okay, so this corresponds to x, so it's a by 4. This corresponds to y, so plus y is plus minus b by 2, so we have minus half b, and in place of z we have 1. Okay, so now we can substitute these values on the right hand side of the identity expression. So we can write 1 by 4 times a minus 1 by 2 times b plus 1 the whole square, as on the right hand side we have x square, so x is a by 4, so we can write a over 4 square plus y square, y is minus b by 2, so we can write minus b by 2 the whole square, and z is 1, so it's plus 1 square. And then we have the pairs, plus 2 into x into y, 2, and in place of x we have a by 4, and in place of y we have minus b by 2, so 2xy. And then we have plus 2yz, so I'll write it in the separate line, plus 2 into, in place of y we have minus b by 2, and z is 1, and the last term is 2 times x into z, so x is a by 4 and z is 1. Okay, so when we simplify this, we are going to get a by 4 the whole square is a square by 16, plus minus b by 2 the whole square will be b square by 4, so it's going to be b square divided by 4, plus 1 square is 1, and here so in the term for 2 into a by 4 into minus b by 2, we can have the 2 and 2 cancel out, so this 2 cancels out with this 2, so we get only a into minus b divided by 4, so that will be minus ab by 4, so that's minus, I'll use the same color, so that's minus ab divided by 4. And then similarly for the next term, we can have this 2 and this 2 cancelling out. So we are left with minus b into 1 is simply minus b. So we'll have minus b. And for the last term, we can have this 2 going into this 4 2 times. So we'll have plus a into 1 divided by 2, so it's plus a by 2. So it's the last term is plus a divided by 2. So this is the final expression for our expansion of this square, x plus y plus z the whole square. Okay, so in place of x we have a by 4, in place of y we have minus b by 2, and in place of z we have 1. So we get this expression, which is our final answer: a squared by 16 plus b squared by 4 plus 1 minus ab divided by 4 minus b, which is this term, and plus a divided by 2. Okay, so we have used the identity to expand this particular expression here. Okay, let us next do or solve one problem from the exercise set using the concept of factorization. Okay, so we'll use the identities to factorize an algebraic expression, and we'll do that with one of the exercise problems. So we have question number 5 from the exercise 2.4. I'm doing one of them. There are multiple factorization problems within question number 5. I'll just be solving one of them, and you can do the others as an exercise. So the expression given is 2x squared plus y squared plus 8z squared minus 2 root 2 xy plus 4 root 2 yz minus 8xz. Okay, so if you look at this, this is taking the form of x squared plus y squared plus z squared plus 2 times xy plus 2 times yz plus 2 times xz. Okay, so that is basically the identity for x plus y plus z the whole square. So we just basically need to figure out what is x in this particular expression, what is y, and what is z, and then we'll be able to factorize this particular expression. So we need it in the form of x squared, something the whole squared. So since we have 2x squared, we can write that as the 2x squared can be written as let me first write down the entire expression. So we have 2x squared plus y squared plus 8z squared minus 2 root 2 xy plus 4 root 2 yz minus 8xz. Now we can write this the first term 2x squared as root 2 times x the whole square. So we can write it as root 2 times x the whole square. So when we square the root 2 times x, root 2 square is 2 and x square is x square, so we'll get 2x squared. But we need to make sure that whether this is positive or negative, whether it is plus root 2x or minus root 2x. And for that, we need to look at the hints in the expressions which are in pairs. So we have the xy pair, the yz pair, and the xz pair. So clearly we see that the yz pair is having a positive term or positive coefficient. So that means both y and z are having the same sign. So they are both either positive or both negative. So let's consider that they are both positive, in which case if y and z are both positive, then in this term where we have y and x, since y is positive, x has to be negative. Okay, so the x has to be negative. Similarly, if y and z are both positive here, so that means z is positive here, and there is a negative sign in front of this xz combination. Therefore, x has to be negative. Okay, so we'll use this idea to examine the expression and identify which of our variables is going to be positive and negative. So by looking at these last 3 terms, we are able to figure out which of the variables is positive and which of the variables is negative. So clearly since the yz term is positive, so we can have y and z to be both positive, and the only term which is negative is x. So x is negative, y is positive, so negative into positive, we get a negative sign in front. Similarly, x is negative, z is positive, so negative into positive, we have a negative sign. Okay, so we can write it as minus root 2x the whole square. So minus root 2x the whole square is 2x square. So we'll keep the y as still a positive number, so it's y is the whole square, and the z is 8z squared. How can we write 8z squared as a whole square? Okay, so we need to write it as some form of a whole square. So what is the square root of 8? Basically, we have to write the square root of 8. So the square root of 8 is 2 root 2, and we have z and squared. Okay, so 2 root 2, when we square it, 2 square is 4, and root 2 square is 2, so 4 into 2 will give us 8, and z the whole square is z square. So the square root of 8 is 2 root 2, so we have 2 root 2 z squared. Okay, so we have got the first three terms as x squared plus y squared plus z squared. So in place of x, we have minus root 2x. In place of y, we have y itself. And in place of z, we have 2 root 2z. So now the next pair terms is, the first terms in pair is 2 times xy. So plus 2 times, our x is minus root 2x. So we'll write it as minus root 2x. And our y is y as it is. And then we have the next term, it is plus 2yz. So plus 2 times y is y, and in place of z we have 2 root 2z. And finally for 2xz, so it is plus 2 times, in place of x we have minus root 2x, and in place of z we have, let me write this slightly smaller so that I can fit it on the same line. So it will be plus 2 times xz. In place of x we have minus root 2x, and in place of z we have 2 root 2z. Okay, so that's 2 root 2z. Okay, so that's our final expression, and we just have to simplify this and see how it relates to our right hand side of the identity. So we have root 2x the whole square plus y squared plus 2 root 2 z the whole square plus 2 times x into y. So in place of x we have this term, the first term, minus root 2x. So when we multiply this, we should get this term. So 2 into root 2 with a minus, so we have minus 2 root 2, x into y is xy. Then we have this term of y and z, 2 into 2, 4 into root 2 is 4 root 2, y into z is yz. And then we have the last term, it is minus 8xz. So we have 2 multiplying with this 2, so that's 4. And then root 2 into root 2 is 2. 4 into 2 is 8. And we have a negative sign here, so it's minus 8. And x into z is xz. So clearly, this is an expansion of these terms, root 2x, that is negative root 2x, plus y plus 2 root 2z the whole square. Okay, when we expand it, we're using these values for x, y, and z, we get this particular expression. So therefore, we can write this as minus root 2x plus y plus 2 root 2z the whole square. So that is basically equal to, since it's square, we can write it as root 2x, negative root 2x, plus y, plus 2 root 2z multiplied with itself. So that's minus root 2x plus y plus 2 root 2z. Okay, so we have factorized this expression into its factors. So the factors are minus root 2x plus y plus 2 root 2 z. Okay, so this is basically a square of this factor, gives us the expression that we have factorized. Okay, so now we have seen examples of how to expand the expression, and also an example of how to use the identity to factorize a given algebraic expression, and we will also use some of these identities to even compute some calculations. So in this particular session, we have seen how to use the identity for x plus y plus z the whole square. Okay, it's a trinomial with a power of 2. We have used this identity to expand expressions of trinomials power 2, and also we have seen how to factorize expressions using this identity. Okay, and in the next video we will see how to use the cubic identities, which are identities number 6, 7, and 8. So this particular session has focused only on identity number 5. So in the next video, I will be focusing on identities numbers 6, 7, and 8, which are all identities with the power of 3, with a degree of 3. And we will see again how we can use those identities to factorize algebraic expressions and also to evaluate certain expressions to solve them. Okay, we'll stop here for this particular session, and we'll continue with our discussion of the remaining 3 identities, and we will do a lot of examples along with some exercise problems in the subsequent video to illustrate the process.